Same topic. The key is to get one step right. Okay? Set up with cell references. Okay? Now, if you're doing modeling with functions, the key in continuous modeling figure out what happens in a typical interval of the independent variable. Okay? If you know what happens in a typical interval of the independent variable, then you can think about a trapezoidal graph. Okay? Because that's all you're doing with a trapezoidal graph, right? You break things into intervals and figure out what happens in your typical interval. And that corresponds to the picture we saw yesterday where you got xi minus 1, xi, f of xi minus 1, f of xi. Okay? If you can do this for the typical interval, then you've got a formula that allows you to do the whole trap graph, right? Whatever your function is, you just do this for that function, okay? But the picture you have here in the labeling of this picture is always the same. Your slope is f of xi minus f of xi minus 1 divided by xi minus 1, right? Your area is the average of these two, f of xi minus 1 plus fi all over 2, multiplied by xi minus 1, which is your width. Average altitude times width. Very easy to understand. With practice, it becomes ingrained. Okay? Then, you can set up your trapezoidal graph. We're going to do that in a while. Okay? Now, I've told you that the area under a curve between A and B, where your function is f of x, is just the integral of f of x with respect to x, where x goes from A to B. It's the limiting value of what your trapezoidal graph would give you if your points all became very, very close together, okay, as they approach 0, okay? As the spacing approaches 0. So you can write out the integral, okay? Now, it can get more complicated. I'm going to give you one more thing, and then we're going to go to lunch. I'm just going to give you the statement, and you can ponder it, okay?